Hi. All right, let's talk about secrets. So I'm going to read you this opportunity canvas, then we'll go through the story map. This is work that's in progress right now to add secrets into the system. It should fix a bunch of issues people have talked about with the current way, which is pretty hacky, where you like put secrets in through the CLI. So DevOps builders who want to author assets, or people working with providers other than AWS who want to test it against, or who want to test System Initiative against different environments that require multiple credentials, have a problem, which is they have to put their secrets into the CLI, which then hard codes them into the system. There's no new easy way to add new functionality for new cloud providers, and there's no security at rest for the secrets. You just write them to plain files, and it is what it is. So today, people solve this problem by just sucking it up and using the launcher to pass credentials the way we do today. They run AWS configure through the CLI to do local dev. They can put secrets in props in plain text on components, which a few people have done as they were sort of played around, or they just wait. They decide to come back later when the solution's a little more fully baked. So our solution is to allow you to create new kinds of secrets that are modeled and created through the customized screen. So you'll create a component which then defines the shape of the secret data in the schema. So in the schema, you'll say like, here's the shape of the data that is a secret, and you express that as a prop tree just like you do now. Then you can go view all the existing secrets in one place. So there'll be like a panel that allows you to sort of manage the secrets. New kinds of secrets get authored in change sets just like normal. And you'll be able to create a pre-flight function, which basically sets up the execution environment for the functions that need the credential. So that could be setting up the environment. It could be dropping things off in the right file, whatever it is. Essentially, there's a relationship between the secret and the pre-flight function. So then a component that needs a secret will have props that say, hey, here's a secret prop that I need. They point to a given component type. So like use the schema to basically decide, hey, what are all the schemas that provide secrets? Pick one of those. That's the type that the prop is. And there's a little flyout panel that'll let you select an existing secret or create a new one. Functions that need a secret can then take a secret prop as an input. The list of those inputs comes from the prop tree. So basically, you can track like which secrets need to be there and which ones are allowed. Then when you run a function that requires a secret, we wind up having the secrets encrypted at rest and in transit. The plain text values are never displayed or logged. And then when Lang.js runs the function, it runs this pre-flight function, then the actual function to set things up. So the value users will get out of this is you can securely store secrets. You can define your own secrets, which lets them author assets that need them. They can manage their existing secrets, create new ones at runtime, and all the benefits of the composition that happens inside System Initiative still apply. So you can reuse them, organizations, relationships, instances, all that stuff sort of works the same way. People will know that they can use the new secret subsystem because we'll change the tutorials, we'll change the launcher flow so that it no longer prompts you. We'll talk about it on Discord. We'll write some technical blog posts about exactly how the security posture works. We'll run demos, all those sorts of things. We'll know people are actually getting the goodness because we can track contributions for components that use secrets, the number of actual secrets people create, the number of types, and then the user experience around credentials. So people should file less bugs or complain a little less about how secrets get handled. So the business problem this solves for us is it enables people to author across more providers. It allows us to offer a more integrated solution, right? So there's more, like, it does more for you. And you really can't use System Initiative in production without it. Our budget is 4 weeks, which ends September 18th. So budgets for us are more like an estimate, right? So it's us saying, how long do we think we'll take to work on this feature before we readjust whether or not we think it's still worth working on, what have we learned, all those sorts of things. Business metrics we're tracking are looking for a production user, obviously. So eventually we want to see that count go up. We should see the number of integrations with service providers go up, and the number of folks who want to use System Initiative should also go up. So moving on, we also create, from the opportunity, we then create what's called a story map. Before we do that, we create a persona. So our persona for this one is our friend Patch. So Patch is Wolverine's secret identity. He works at Blue Sky. He used to work at X. Has a lot of secrets. He's an open source collaborator. He likes managing secrets across, has to manage secrets across multi-cloud growing infrastructure. So thinking about how do I manage all these things across the infrastructure that's growing with Blue Sky is difficult for Patch. And then migrating between various cloud providers means he has more credentials to manage, right? So as they think about being multi-cloud or doing those sorts of things, like Patch has to figure out how to put all those secrets into the system. Patch likes having one place for keeping all the secrets that manage the infrastructure. So he likes having one sort of place to go to deal with it. Likes to keep the complexity of the credentials well organized. So when he thinks about how do I want to refer to those credentials or how do I want to see them, like he wants that to be a simple, organized process. Wants an easier way to isolate resources than sort of big Terraform repos provide. So if you think about how you manage secrets or how you inject them across large deployments, it becomes quite hard when the repo grows large. So wants a better way to think about isolating those things. And needs to set the credentials for others without sharing the actual secret. So it's Patch might need to set the secret up because he has the credentials. Somebody else has the ability to consume that credential, but not to actually see what it is. So by implication, we should easily be able to support multiple types of secrets. We should be able to connect the right type of secret to the right usage, and we should be able to delegate the credentials across the team. So the map is used to understand sort of how are we going to approach solving this problem. So the way you can read these maps, I won't bother reading every single thing in the map, but essentially we're going to look at this part here, which is a backbone. What we're going to say is you read them left to right, and you can think of them as the user journey, right? So somebody comes in, they create a new secret schema. Then they can attach a pre-flight function to that schema, which will get used to authenticate it. Then we'll add a new secret type as a property to the other schemas that need it. So, if the AWS credential is needed on the AWS EC2 component, right? So we'll add that property. Then you can go create new components on the diagram. There'll be a little secret prop in your component. When you click it, it displays a popover of the secret types that match. So it says, hey, here are all the AWS credentials you could use for this component. Which one do you want to use? Then you can add a new secret, or you can pick an existing one, right? So we can pick an existing secret to use. At that point, it's wired up, or you can add a new one. You can also do that through sockets. So while those properties are available everywhere, they can also be driven by a socket, which gets you composition and frames and all those sorts of things. Then you'll be able to execute a function that needs it. So like a qualification could run that then uses that particular credential, which then authenticates to the system. And then you could go to a secrets management screen and centrally manage all the different secrets in the system without having to go visit every single component. And then you will write blog posts and explain to everybody how it works. So then we're going to do that in a couple of different slices. So we think about slices as pieces that we can build that allow us to learn something critical or know that we're on the right track. So we try to break the work up into slices that work across the map so we can see, are we heading in the right direction? Is our approach right? So the first slice is just creating and consuming a secret. So can we create a secret and then consume it out the other side? So we're not so much wiring that function up to the functions yet. We're just thinking about, can we create a new one? Can we put them in the system? Does the encryption work again? All of those sorts of things. I say again because a lot of these subsystems actually already exist in System Initiative. They just have been sort of hidden away while we got ready to ship. Then we're going to wire in function execution. So over the top, underneath, basically, all of that work that we've done. Then we'll do the work to handle like the pre-flight functions, to think about the in-flight decryption and a lot of those pieces for actually executing the functions that need secrets. And then we'll focus on expanding secret management. So working to add in the larger screen that allows you to work your way all the way through it, to be able to, create and delete secrets, rotate them, sort of those sorts of behaviors. So there you go. That's secrets in a nutshell. So one last thing. So this is sort of a simple mock of how it might work, right? So you'll drop an EC2 instance in here. It'll have a property that says it needs an AWS credential. You'll click it, a little pop-out will show up. You could add a new secret, or you could select an existing one. Then you have a credential that can be driven, right? So you can use a credential to drive the instance, and then that automatically sets the credential correctly. So if you set the AWS secret credential on this, and then you drove the EC2 instance, it would automatically get it, which means it would also work when you compose it in a frame. All right. Thanks for watching. See you later.